Okay, so once more, good evening, everyone. My name is Jomark Bakiran, so I will be your instructor for tonight. Okay, so furthermore, if you have questions after this live stream, feel free to connect with me, to message me in LinkedIn. Okay, so without further ado, let's now begin. Opening now, showing you SolidWorks. Okay, so this assembly was made, of course, initially through a sketch. So notice here, I have a single SolidWorks part consisting of seven bodies. So once more, the topic this evening is multi-body. Once more, I'm showing you these are multi-body in a part. Okay, and from here, we will turn this into a dynamic assembly. Okay, so let's now begin. Let me quickly restart SolidWorks. Okay, back in SolidWorks. In the welcome screen, let's create a new part. Heading over to new, and I'm going to double click part. Okay, our next intent is to insert that DXF file into SolidWorks. But first, let's select a plane which will serve as its destination. I prefer the right plane. Left click on that. Heading over to Insert. Going down under DXF. And on your exercise files, I want you to select multi-body.dxf. Double left click. Next, I prefer to import to part as 2D sketch, and I want you to disable import as reference. Selecting finish. And if you are not yet familiar with sketching, highly suggesting you check out this course in the library. I prefer having a larger screen real estate. Let's hide our task pane, and to do that, let's head over to View under User Interface, and let's disable task pane. Let's start adding dimensions. Heading over to Sketch tab, selecting Smart Dimension. Let me define the length of this vertical line to be 80. Next, selecting this vertical line and the center point, leaving this to 15. Smart Dimension still active, selecting this center point and this center point. This one to be 50. This center point and this vertical line to be 30. So notice I'm still retyping that value just to make sure. Selecting this vertical line, this one to be 33. This line to be 170. Hitting enter. This line to be 50. Hitting enter. The diameter of the circle to be 20. Length of this line to be 80. Diameter of the circle to be 5. Next, I prefer the diameter of the circle to be 35. And moving forward, let's add relations. I'm going to hit escape. Let me start out by selecting this line to be vertical. This line to be horizontal. And in addition, let's turn on the visibility of those relations by heading up under this drop down and selecting View Sketch Relations. Notice the appearance of this green boxes having the relations. Moving forward, selecting this vertical line. This one to be vertical. This line and this line, holding control, to be perpendicular. Okay, so let's continue adding relations. And once more, shout out to our friends in Binildian Industrial Designers Bind. Let me focus on this circle. So selecting this circle, left click, heading over to our feature 3, holding control and selecting origin. And we're going to add a coincident relation. Zooming out, let's check the placement of our support. Let me grab this line, left click and hold to determine what needs to have a relation. I'm going to hit undo and select this vertical line, add a vertical relation. In addition, let's add a dimension, hitting S and selecting Smart Dimension, selecting our origin or the center point of that circle, selecting this line, a value to be 23. Double click our mouse wheel to zoom extents, hitting escape, checking, hitting undo. Let's add a tangent constraint between this arc and this line. Selecting tangent. Same with this arc and this line. Holding control to select them both. Selecting tangent. Inspecting the sketch. Coincident with our origin. So with our center point selected, I'm going to hold control and select our origin. Selecting coincident. And I'm going to select this relation and hit delete. Let's zoom out. Next, I want this arc and this circle to be concentric. This point and this point should be aligned horizontally. Let's now check. Selecting this center point, left click and hold, and moving this point. From here, we now have an insight on what our assembly will be based on creating a sketch with relations. Let's continue adding relations, selecting this circle, and this circle. And this 3, I want them all to have an equal diameter. Same also with this circle, and this circle. I want them all to be equal in diameter. Next, let's turn this line and this line to be a construction geometry. And this sketch over here represents the shaft, which is this line having a length of 170 millimeters. So let me select this line and this construction geometry. I want them both to be equal in length. Let's zoom in and define the dimensions of this shaft. Let's hit S on our keyboard, selecting Smart Dimension, selecting this line and this line, placing our dimension here, hitting enter. Same with this line and this line, placing our dimension here, hitting enter. Lastly, this line and this line, left click here to place the dimension, hitting enter, and holding control to select this 3 dimensions, and head over to our properties, selecting this symbol to identify these are all diameters. Hitting enter and left click. Let's zoom extents. Let's inspect the sketch of this shaft. So notice we need to apply relations once more. Selecting this line, let's turn this into a construction geometry. Select this line, hold control, selecting this line, and finally the construction geometry. Let's make them symmetric. Same with this line, and the construction geometry. Selecting symmetric. This line, and finally the construction geometry, making them symmetric. Let's inspect. Selecting this point and this line. Let's have them coincident. Let's zoom out. Same with this point and this line, making them coincident. Let's inspect this point as well. With this point selected, selecting this line, making them coincident. This point and this line to be coincident. Inspecting, making this line to be vertical. Let's add dimension, hit S. Selecting smart dimension, let's define the distance between these two lines to be 15. This line and this line to be 1, 4, 5. And this line and this line obviously to be 25. Okay, so I'm going to hit undo. Inspecting once more. So notice we need to apply a horizontal constraint on this construction geometry. Selecting make horizontal. Inspecting. Moving forward. I want this endpoint and this vertical line coincident with each other. Selecting make coincident. Let's inspect our sketch. Let me grab this endpoint. Looking nice. Let's zoom extents. Okay, so we're making a progress. Okay, with the sketch in place, let's now create the bodies. Let's now head over to Features, selecting Extruded Boss Base. We are now prompted to select a sketch or an existing sketch. Selecting this line. And let's change the direction to mid-plane. I prefer this, having a thickness of 2. Zooming in. And under the sketch contours, I prefer deselecting this circles. And finally, selecting the green check mark. So I'm right-clicking, selecting OK. And notice on our design tree, we now have a folder containing one solid body. Moving forward, I want to tear out and remove this toolbar. Left click and hold and closing this one out. In addition, I would like to update our sketch to have a hole here. So let's head back to our design tree, selecting sketch 1, and let's edit this sketch. Zooming in, and under sketch, let's create a new circle. Let's place its center point here. Left click, hitting escape. And I want this circle to be equal in diameter with this circle. So selecting equal. And let's exit out of this sketch. Head back to Boss Extrude 1. Selecting Edit Feature. Heading over to Selected Contours. Left click here and let's deselect or select this circle. And selecting the green check mark. So notice we now have an additional hole. Let's create another body. Heading over to our sketch 1. Let's turn on its visibility. Selecting show. Head over to our solid bodies folder. Selecting Boss Extrude 1. And turning off its visibility. Hitting S and selecting Extruded Boss Base. Selecting this line. Notice this is now enabled as a thin feature. So let's disable this. And I want to clear out this selection or simply selecting delete. Left click here and left click. Selecting this contours. Heading over to directions, selecting mid-plane, once more thickness to be 2, and hitting enter. Notice this time we now have our second body, which is now Boss Extrude 2. Moving forward, let's create our shaft. And the tool to be utilized here is the revolved boss base. And notice our axis of revolution needs to be a solid line. So let's head back to our sketch 1. Let's edit that sketch. Selecting this line, turning this back to a solid line. Exiting out of this sketch. Let's now select Revolved Boss Base. Selecting this line. Heading over to Selected Contours. Left click. And select this contours. Selecting the green check mark. Zooming out. And let's turn on the visibility of Boss Extrude 1. And as quick as that, we have created multiple bodies in which later on will become parts in Solidworks. Moving forward, let's create the pins for these holes. Head back to our design tree and we are going to turn off the visibility of these 3 bodies. Let's now hit S and select Extruded Boss Base. I would like to extrude this as a cylinder. The direction to be mid-plane and the overall length to be 30. Hitting enter. And let's create another circle. Let's head back to our first sketch, which is sketch 1. Let's edit this sketch. Let me zoom in. I'm going to hold my right mouse button and move to the right to create a circle, placing our center point at the origin. Left click. Hit S and select Smart Dimension. I want the distance between these 2 circles to be 2 millimeters. Hitting escape and let's exit out of this sketch and update our pin. Hitting S, let's extrude once more, selecting Extruded Boss Base, selecting this circle. And under direction, changing this to mid-plane. Overall length. In addition, this will serve as a stopper. Let's key in 20. Hitting enter. And hit enter once more. Recall we have turned off the visibility of the bodies. Notice boss extrude 4 merged with extrude 3 to form boss extrude 4 body. Heading back to isometric view, control 7. Let's create the hinge. And take note, our shaft will be piercing through this hinge. Let's hit S for Solidworks shortcut keys, selecting extruded boss base, selecting this circle. Under direction, changing this to mid plane, and distance to be 30. Hitting enter. Hitting enter once more. Hitting S, selecting extruded boss base. Let's extrude this circle, changing the direction to mid plane. Length to be 20. And hitting enter. In this moment, we will not be creating the hole here. And that one will be created when this body is finally turned into a part. Let me turn on the visibility of the rest of the bodies. Left click boss extrude 1, holding shift. Left click on revolve 3. Selecting show. And for the pin and hinges, on these positions, we are simply going to create a copy of this 2 bodies. So selecting boss extrude 4 and extrude 6. Heading up under direct editing tab, selecting move copy bodies. Making sure copy is ticked or enabled. Let's move this somewhere around here. Selecting the green check mark. And because we have the support, which has a thickness of 2 millimeters, we are going to move this 2 faces by that value. So let's head up to direct editing once more, selecting move a face, selecting this 2 faces, moving this arrow to the left to be exact, keying into, hitting enter, enter once more, repeat that command, selecting move a face, selecting this face and this face, moving this arrow to the right, keying in 2 for the distance. Hitting enter. Control 7 for isometric view. And those are the rest of the bodies that will be needed to turn this multi-body part into a dynamic assembly. With all bodies in place, let's now turn all of these bodies into parts. And to do that, we're going to head up to insert under features, moving down and selecting save bodies. We are now prompted to select a body. Let me head over to our resulting parts, left click here. So notice it highlights this body. I'm going to double left click on this, and I would like to name this as support. Hitting enter. Next. Selecting number 2. Notice it highlights this body, which will serve as the arm. Heading back, double left click on none, and let's save this as arm. Hitting enter. For number 3, let's name this a new part as double left click, hinge dash A. Heading to number 4, double left click on none, naming this pin to be pin B, hitting enter. For number 5, this will be our shaft, naming this as shaft, hitting enter. For number 6, this will be pin dash A. For number 7, this will be hinge dash B. Hitting enter. Leaving the defaults here. And finally, selecting the green check mark. And if this window appears, simply select yes 7 times. And let me show you the list of parts created. Notice hinge, pin, shaft, arm, and support. With the bodies now saved as parts, we can now head up and create a new assembly. Double left click on this. And from here, let me show you the extracted files. I can left click and hold and drop support in place. Selecting the green check mark. Now the downside of saving bodies, notice as we head back to our multi-body part, let's say we have a design change. Let me head over to sketch 1, selecting edit sketch. Let's say 50 was modified to 80, and leaving the sketch, notice as we head back, hitting Control Tab to the imported support part, the distance still with these 2 holes is still 50. This means if we utilize a save bodies, the linkage between the sketch and the saved part are now broken. Let me hit escape and close this window out, selecting don't save. Let us go back in time before we perform the save bodies. I'm going to head over to our design tree and notice this blue line. I'm going to left click and hold and move this up on a save bodies 1, release. So notice I have suppressed this command. A better option would be heading over now to boss extrude 1. I'm going to right click on this and finally select insert into new part. Let me select this ellipses and save this one out, this time as support. Let me overwrite this existing part, selecting yes, and selecting the green check mark, selecting yes. Let's head back to our multi part, and this time let's re-update our sketch 1. Let's say this time to be 100. Hitting enter. Let's exit out of this sketch. Hit Control Tab. And notice as I measure the distance between this hole and this hole, they are the same with the value indicated on our sketch 1. So now we now have a master part model. Let me head back to our sketch 1 and bring this back to 50. Exiting out of this sketch. Next, let's now save or insert all of these bodies into a new part. But first, let me copy our target location, hitting Control C, selecting Boss Extrude to, right click, selecting Insert into New Part. Let's place this on this location. This one to be arm, hitting Enter, selecting the green check mark, selecting Yes, heading back to our master part model. And you may be wondering, what if we select multiple bodies and insert them into a new part? I'm going to right click, insert into new part, and let's save this out as check. Hitting enter, selecting the green check mark, selecting yes, and notice we need to select and insert into new part each body. Let's close this out. Control F4. Hitting Control B to rebuild. Let's insert into new part the shaft, which is represented by revolve. Right click, selecting insert into new part, naming this as shaft, hitting enter. Right click, selecting OK, selecting yes, Control Tab, selecting boss, extrude 4, right click, insert into new part. Let's name this as pin-A, right click, selecting OK, selecting yes, Control Tab. Let's finish this one out. Selecting boss extrude 6, right click, selecting insert into new part. Let's name this as hinge-A. Hitting enter, right click, selecting OK, selecting yes, Control F4. Next, selecting move a face of 4, right click, selecting insert into new part, naming this as pin-B, right click, selecting OK. Let's don't show this again. And finally, selecting move a face 4, right click, insert into new part. Let's name this as hinge-B. Right click, selecting OK. Control Tab, hitting Control B. Okay, so moving forward, we are now about to create a new assembly document and bring over our newly created parts. Okay, so in addition, shout out to Jenaline Contreras Aldovino, yes, for inviting new friends to join us in this live stream training. Shout out also to our JPSME, Batangas State University. Okay, let's now go the extra mile. I'm going to hit Control N to create a new Solidworks document, specifically a new assembly. Double left click on this. Next, let's start to bring over pin A first. Selecting the green check mark. Next, I'm going to hit Control S to save this new document. Selecting Save All and selecting Rebuild and save the document. Saving this on my preferred location and naming this as ASCII dash hold down clamp. Hitting enter. And one of the best practice when creating new parts is to make sure that the origin is situated at the center. Let's select pin A selecting open part, and clicking on origin. So notice it's at the center. Control Tab to head back. Let's bring in another part, hitting S and selecting Insert Components. Let's scroll down, looking for support, left click, moving over to our graphics area. And I prefer placing it here, left click. Next, I'm going to select this face and this face, holding Control to select them both, hitting S and selecting Mate. Accepting the default, which is concentric, selecting the green check mark. Next, let's add another mate, selecting this face and the face of our pin A. Accepting coincident mate, selecting the green check mark. And finally, let me head over to support, selecting top plane and the top plane of our parent assembly. Holding Control and accepting the default coincident mate, selecting the green check mark, hitting enter. Next, let's add a splice of a sheet metal, heading over to support and selecting open part. Now, if you don't have a sheet metal tab, just head over to a blank space, right click under tabs, enable sheet metal. Heading over to convert to sheet metal, prompted to select a fixed entity. I prefer this face. Right click, selecting OK, leaving the defaults. Next, let's add an edge flange, selecting this command, selecting this edge, and to be exact, I'm going to key in 40 and hitting enter. Looking nice. And hitting Control Tab to head back to our assembly. Let's move forward by creating another support. And to do that, let's simply mirror out support as a component. Heading over to Assembly tab. And under this drop down, we're going to select Mirror Components. Prompted to select a mirror plane. Let me twirl this down and select our right plane. And the components to mirror will be support. So selecting support, left click. Next, we're going to select this arrow and select Create Opposite Hand Version. Right click and selecting OK and select Save All. Let's now insert the arms, hitting S, selecting Insert Component, selecting arm, placing this one here, and creating another duplicate of or instance of the arm. So what I did is I simply hover over this component, hold Control, left click and hold to create another instance. Let's add mates, hitting S, selecting mate, selecting this face and this face, accepting concentric, hitting enter. Next, I want this face and this face to be coincident, hitting enter. Let's inspect. So let's repeat that step. this time to this arm, selecting this face and this face, accepting concentric, selecting this face and this face. Hitting enter. Let's inspect. And hitting enter once more. Let's now bring in hinge A. Hitting S, selecting insert component, selecting hinge A, dropping this part here. Next, I want to bring in the shaft as well, hitting S, selecting insert component. Let's bring in the shaft and head over to evaluate. I want to measure the diameter of the cylinder, which is 8 millimeters. What we're going to do next is create a hole on our hinge. Let me head over and select hinge A. Let's open that part. In addition, notice our origin is not located or coincident with the center mass of our hinge A. Let me head over to this drop down and turn on View Origins. So notice origin is located below. Our next intent is to move that origin here at the center. To do that, I want you to head over to Direct Editing, selecting Move Copy Bodies. Body to move is this body. Next, under Mate Settings, I'm going to select Concentric, selecting this cylindrical face, holding Control, and selecting Origin. Notice it's now at the center. Right-click, selecting OK. Recall, the diameter of the cylinder is 8 millimeters, and that will go through this hinge. Let's now create that sketch. Heading over to top plane, selecting sketch. I'm going to hold my right mouse button and move to the right to grab our circle command. Let's place the center point at the origin. Left click, hit S, and select Smart Dimension. Diameter for this to be 8. Hitting enter. Enter once more. And let's exit out of this sketch. Let's now create a circular cut extrusion, hitting S, selecting extruded cut, selecting this circle, heading over to direction, changing this to through all both, and hitting enter. In addition, before we create the thread here, I prefer adding chamfers, so selecting this edge and this edge. Heading up to Direct Editing, selecting chamfer. The value, I'm going to key in 1, hitting enter. To create the thread, we need to have a plane first. Let's switch tabs, heading over to Features. Under Reference, selecting Plane. Let me select the face of the cylinder for the first reference, and for the second reference, let me head over to our design tree and select top plane. Next, for the second reference, I'm going to enable at angle, and I'm going to key in 360. Looking nice, selecting the green check mark. Let's now insert the thread, heading over to Insert under Features and selecting Thread. Hitting the space bar. Thread location, let me zoom in, select this edge. And for our next reference, it will be the newly created plane. For the end condition, let's key in 20. Inspecting. And for the type, it will be a metric tap. The size to be, since it's 8 millimeters in diameter, we're going to select M8 by 1. Leaving the defaults, I'm going to right click and select OK. Let's head back to our assembly, hitting Control Tab. Zoom in. I'm going to select this cylinder or that face, this face. Hit S, selecting mate. Accepting concentric, hitting enter. Let me add this face as well. So selecting these two faces, hitting enter. And finally, let me head over and select our right plane and twirl hinge A down, select its right plane as well. Mate type, coincident, hitting enter. Let's check. Moving forward, let's now apply the thread on this shaft and add the hole for hinge B. Let's now focus on the shaft. Selecting the shaft, selecting open part, heading up to insert. Under features, let's select thread. Target the thread location. I'm going to select this circular edge. And for the end condition, let's change this to up to selection. And that selection will be up to this circular edge. For the type, changing this to metric tap. For the size, let's make sure this is M8 by 1. Lastly, for the thread method, changing this to extrude thread and selecting the green check mark. Let's head back to our assembly. Moving forward, let's bring in hinge B. Hit S, selecting insert component. Let's select browse and selecting hinge B, selecting open, placing this part here. Hit S. Let's now apply mates. Select this face and this face. Accept concentric mate. Same with this face and this face. Accepting concentric mate. And finally, let's select our right plane. Head over to hinge B and select its right plane as well. Accepting coincident, hitting enter and enter once more. We're nearly done. Let's check the diameter of this cylinder. Heading over to evaluate, selecting measure, selecting this face, diameter to be 5. Let's close this out. Open up hinge B and let's create an extrude cut. with a diameter of 5 millimeters. But first, let me inspect. So notice here our origin is way down our solid body. So let's move that. Let me first turn on the visibility of our origins. Head over to direct editing, selecting move copy bodies, body to move. Is this only body? And for the mate settings, I'm going to select concentric, selecting the circular face and our origin. Hitting enter, and enter once more. And finally, let's create that circular sketch, selecting top plane, selecting sketch, hitting S, and selecting circle. Let's create that 5 millimeter diameter circle, hitting S, selecting smart dimension, and making this to 5. Hitting enter. And let's exit out of this sketch. Hit S, selecting extrude cut. Let's change the direction to through all both. And hitting enter. And I prefer adding a chamfer as well to this two edges, selecting chamfer and value to be 1. Hitting enter, and let's head back to our assembly. Let's wrap things up and bring in the missing pieces. I'm going to hit S and let's insert components. Let me browse through that missing part, selecting pin B, placing this one here, and hit S once more, selecting mate, selecting this face and this face, accepting the default concentric mate, selecting this face and this face, accepting concentric, and finally let's select our right plane and the right plane of the pin B. Selecting right, accepting coincident, selecting the green check mark, hitting enter. Let's now insert our shaft to the hinges. Let me rotate this hinge first. Let's insert mates, hitting S, selecting mate. And let me zoom in here on the thread of the shaft, selecting this face. Next, for us to easily select the cylindrical surface for hinge A, I'm going to change the visibility of our assembly to wireframe. Zooming in, this is our target cylindrical face. I'm going to right click, selecting select other, and let's cycle through. And this is the target face. Accepting concentric mate, hitting enter. Let's revert back to our display style, which is shaded with edges. Next, selecting this cylindrical face and this cylindrical face. Hitting enter. And enter once more. And let's check. Congratulations! From a skeleton sketch, you have created a dynamic assembly coming from a multi-body part. Let's recall and bring in our multi-body part, hitting Control Tab. I'm still holding Control, selecting 06 begin, and let's check if we revise this dimension. So I'm heading over to Sketch 1, selecting Edit Sketch. Let me change this to 80. Let's exit out of this sketch, hitting Control Tab. Notice it's updating. Let's check if our assembly updated to what the new multi-body part is. Selecting measure, selecting these two cylinders. Notice both of them are at 80 millimeter distance. Congratulations, and that's modeling multi-body part in Solidworks. Great job. Okay, so once more, thank you so much for all who joined us this evening. Maraming salamat po. So once more, inviting you to unite with us in Solidworks Users Philippines for you to be updated on our upcoming live stream training. Okay, so once more, flashing you also, don't forget to complete the course. Okay, all instructions are here. Okay, pasting also now the link for you to join. The instructions on how to claim the certificates are also here. So once more, register and enroll in this course now while it's still free. And again, thank you so much for joining us this evening. Thank you to all our partners, student organizations. Okay, so again, if you have questions, comments, suggestions, feel free to reach out to me in LinkedIn. Okay, so once more, thank you so much to our partner organizations. Okay, and see you next time for another SolidWorks Users Philippines CAD training.